And you know what, I was thinking that because we're going to be doing this seminar presentation in English, maybe Hannah and I will do a super quick repeat of our presentations in English for those who don't understand Swedish. Hannah, do you want to say quickly who you are?
Yeah, sure. I'm a PhD student in language and culture, as Bodil just said, in Swedish, Språk, kultur. And I do research on robots and how people can coordinate their actions better with robots when robots use sounds, different kinds of sounds.
And I'm Ericka Johnson, and I'm over at the Department of Thematic Studies, which is an interdisciplinary department, where I'm leading a group of researchers who are looking at care robots and some of the ethical and social consequences of those robots. And today we were thinking we're going to talk a little bit about a seminar series that we've had for the last year and a half, maybe, on AI and society. The seminar series, maybe I'll just quickly present it, was meant to be sort of a meeting place for a lot of us who are looking at AI from different interdisciplinary aspects, mostly the social sciences and humanities, but not only. We wanted it to be also a place where we could meet people who are working with AI from the the technology faculty. And we've been doing lots of readings of sort of basic texts and then some newer texts. And we thought today we would talk about 3 of those texts and sort of how it has generated conversations across different disciplinary backgrounds and what those conversations have shown us both about AI, but maybe also about approaches to AI and technology and society.
Absolutely. We thought we would start by asking the question, AI in society, where is it even? Have you seen any AI today? Maybe you've been on Instagram and used some filter to make your face look nicer. Has some face recognition algorithms in it. Maybe you've driven in a car. Maybe you have a bit of a fancy car that has some street sign recognition showing you how fast you should go. Maybe, and I think probably all of you, have used your email. Who has used their email account today? Yeah, pretty much everyone. I'm pretty sure you know this little folder there, the junk folder. This is a screenshot from my junk folder. You can see the typical stuff. Money was donated to you. And AI can learn these patterns in these emails and categorize them as spam. And then they end up in this folder. So this is just one example where we all, especially here perhaps at the university, where we all write emails every day or receive them, kind of get in touch with artificial intelligence or machine learning algorithms in our daily lives. So just to sort of like highlight that we kind of are now in a situation where AI is really kind of coming through in our everyday lives a lot. So it's quite important to discuss this. So Ericka has said a bit about our seminar already, and we're going to walk through 3 different texts that you will recognize. I think we can start right away. So for a long time, the question was, can machine think? And people have been very fascinated with this question. I mean, in the Middle Ages already, we had the first types of robots, so-called automata, where people tried to build human-like machines. So this question, like, can we build something that is a bit sort of like a human, has been around. And sort of from a philosophical perspective, the question has been very much, can machines think like humans? In 1950, Alan Turing came and said, this question is actually crap. Let's remove it. We can't address it. It's much too big. Can machines think? Let's replace it with the imitation game. And some of you might know this already. Today it's better known as the Turing Test. And we thought we will present this. We read the original paper in the seminar, so it's quite interesting to see. This is sort of the test as it's known today. We have this person who's going to do the test. That's us now. We are looking over the shoulders of the tester, and we're in front of a wall. But through this wall, you can type with a keyboard, and behind the wall, there's a computer and a human, and you're chatting with them through the keyboard. And I didn't put on there's also, of course, a screen where you see the text appear, but it's very much, you don't see them, but you have to figure out who is the human and who is the computer by just chatting to them, asking them questions. You can ask anything Turing is sort of like describing this in the paper, what kinds of questions you might ask them to calculate something, and then maybe you can figure out by the speed that they answer, like, is it the human, is it the robot, is it the computer? So then the computer passes the Turing test when the human says, this is the human, to the computer. So this is how it's often presented. Maybe you've seen this already in some other sort of movie or the AI sort of like discussions. Very famous. Actually, the original paper is like based on a bit of a different setup. So in the original way that Turing describes it, there is sort of the version with a computer, but then he bases it on the actual imitation game. And in that game, we have a man and a woman. And the man tries to deceive, saying, I'm the woman. And then the woman is like, no, I'm the woman, I'm telling the truth. So the computer is essentially in the place of the man. And we were discussing this actually a bit like before the seminar, and Ericka said, like, this is actually interesting because this game maybe hasn't only been invented by Turing, right?
Right. Well, so there's a bit of urban myth around this paper and his idea of the imitation game and the game. The urban myth is that Turing took an existing game that was based on a Victorian parlor game that was like this, where people would enter into a room, two people would be behind a curtain, one man and one woman, and the person on the other side would have to ask questions, get written little answers, go around the curtain with them, and try to guess which one was the man, which one was the woman. The internet will indicate that this is actually perhaps just an urban myth. Maybe there wasn't actually one of these games, but it does play into an existing understanding of the Victorian period full of parlor games that were working towards getting people to socialize, but also understandings of complete differences between men and women, and the idea that we could try to, and here comes some 1980s gender theory, perform our gender in different ways and fool people into thinking that we have a different gender. And it's kind of interesting to think that when this idea, back in the 1950s, was shifted over to trying to get a computer to fool the person to think that it was a human, that it was replacing the man in this dyad and trying to get the man to appear as a woman, or try to get the computer to appear as intelligent as a man. Or there are lots of different ways a person could analyze this and start thinking about what cultural understandings of identity and subject positionality were at play behind the production of this Turing test. And its incredible popularity, because this has become a really popular part of the mythology about our AI and artificial intelligence and our understandings of how we can make a computer think like a human. Or maybe that wasn't the question we wanted to ask.
No, but absolutely, that's sort of like the idea, right? Sort of like this test kind of becoming sort of the milestone. I think there's still like a competition, sort of like, can you pass the Turing test? And I think it's quite interesting to actually go and dig out these old papers and read them and to see like, where does it actually come from? Where do we even start when we say like we have intelligent machines, and what is our definition here?
Or maybe what is our definition of intelligence that we're trying to build the machines to be like? That ends up being one of the questions that we didn't come up with, but talked about in our seminar, and that we got very different answers from within the group of people who were at the seminar, because we come from different fields. We have very different understandings of what the subject is, what the human subject is, where the human subject is. Is it something that is embodied in our bodies? Is it something that is produced through language, produced through relations, in a context or outside of a context? Can it be decontextualized? All of these questions become really apparent when we start to think about what kind of intelligence is then trying to be produced, reproduced, embedded in a machine, and how those shifts are made discursively and materially.
Absolutely. I want to show one more slide regarding this to illustrate again, like, this is how this looks when you chat with a computer to kind of like pass the Turing test. This is ELIZA. It's also quite an old system from the 1960s. And basically it was sort of like a psychotherapist. So you could sort of like chat with ELIZA, and ELIZA would sort of answer in capital letters. So I'm just going to read the first line. The test person that we were now like before looking over the shoulder is sort of typing, "Men are all alike." And ELIZA types back, "In what way?" "You're always bugging me as about something or other. Can you think of a specific example? Well, my boyfriend made me come here. Your boyfriend made you come here. So basically the way that this works is that it's just repeating certain phrases and asking for specifications. The system is not intelligent at all. But it was a demonstration of, this could have passed the Turing test, because you can get the impression, oh, I'm talking to a therapist. And Joseph Weizenbaum, who built the system, also says, ELIZA shows how easy it is to create and maintain the illusion of understanding. So here in this system, you would think like, oh, sure, we can just build this system that would pass the Turing test because we're just behind the wall and we're just chatting with the system. But what does that even mean? What does that even say about intelligence? I think this is really one thing that we kind of come at with our seminar, that we ask, what is the definition of machine intelligence actually based on? Here we have a system where you have a completely disembodied interaction. You type on the keyboard, and I think we all know, like, maybe you can even remember the times when you didn't have like nice chat programs, but were just texting on your phone, some text messages without emojis even. It's very difficult to communicate. So human intelligence uses the body, we gesture, we use our facial expressions. In research here at Leo, we learn even that we can use all kinds of bodily sounds to communicate. Oi, 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 oi. That's also a way to sort of like interact. So I think we have like all kinds of different ways to be intelligent and to communicate, for example. That's kind of my perspective, very much coming from the language department.
But the interesting thing, I think, with this is that, okay, ELIZA was maybe designed and built specifically to prove how incredibly easy it would be to pass the Turing test, and almost in a way to say, hey, the Turing test is not actually saying that much about intelligence. And yet, when ELIZA was demonstrated in many different environments then, and to some extent, I would say, reproductions of it now, often are met with wonder and amazement and awe. Wow, this is actually a really smart system. This is an artificial intelligence that is almost working, almost being the key word often. But anyway, it has had an incredible effect both on the development of AI as a field, through its ups and downs, its winters and its summers, but also through the development of ways that we imagine AI is going to be able to change our lives in the future. And this is something we've seen a lot in the research here that looks at cultural embeddedness of AI or robotics technology, how much they are presented as solutions for problems that we see already now and suppose are going to be bigger in the future. And a lot of it is based on this wonderment that people feel and express over certain pretty early, kind of basic technologies that are pretty fundamental to where we're going today.
Yeah, and they really influence sort of the way that we see this. I think the Turing test is like a really nice example to start from, because it really highlights that Turing maybe wasn't sort of like thinking that far. He was just like, now in the 50s we need an operationalizable definition, or like, yeah, let's sort of like move forward. But until today, this sort of like version has sticked, and we kind of still sit with the Turing test, and maybe people try to change it a little bit, but still like the basic structure is still around. Yeah. And I think that's quite, yeah.
I think we're getting long-winded. We should move on. Next one. Sorry.
We can move to the next theme that we prepared. We're kind of interested in what does it take to make AI systems possible? And I thought we could go on a little journey here. Who of you has an Alexa or a Google Home voice assistant at home? We have one here, yeah. What is a typical request that you might ask? To set a timer. Mm-hmm. So while cooking, you might say, Alexa, can you set a timer for, say, 6 minutes to boil an egg? So we will set a timer and follow through, and we're presenting here the work that's by Kate Crawford and Vladan Joler. It's called Anatomy of AI, anatomy of .ai, and you can look this up after this lecture. It's very interesting. This is sort of what they built. It's massive. It's sort of like a huge graph of what it takes to get your request, to set your timer, and what's sort of like behind when we open and sort of like look what's behind the wall, kind of. We won't have time to go through the entire diagram here, but let's start by asking, Alexa, can you set a timer? You probably have this system set up. It's plugged into the wall, connected to your Wi-Fi. So your request is traveling from your wall, in the cables, down the house, down the road, and eventually we end up in some submarine cables. Perhaps you're traveling with your request to set the timer through the sea, across the Atlantic, to the US. So this is one of the graphs that is in this bigger diagram. I don't know how big it was, or whether you could see it before, but here I think it's quite nice. You can kind of see how the countries are connected. We have sort of Africa appearing quite strongly here. Now we move on, and we're perhaps in the US at Amazon data center. Who is working there making this possible? Because we have the request, but now we also need to translate it. Now we want to set the timer, but the machine needs to understand what do we actually want. So we have a lot of labor going into this. We have some engineers and data scientists paid for their work, of course, but there's also other people connected to that. There's researchers who are doing some research that they will then later maybe get sort of like used in companies, getting the first ideas. Researchers are usually getting paid quite okay, like we don't have to complain. But who else is involved? Maybe we ask some students to participate in some experiment. Maybe they are even labeling data for free. I did that as a student, actually. I was in a system where you needed to kind of participate in a certain number of experiments to gain experience. And then as part of that, I ended up sitting there for 3 hours labeling faces. Happy, sad, you know. That's labor, and for me, like, it doesn't hurt too much. It's just 3 hours. But if you add that up at all the universities in the world where students do this kind of work, it's kind of building up. And that's not the only type of work, of course. We also have other types of workers. In developing country where labor is cheap, we have so-called Amazon Turkers. These are people that you can pay very minimum amounts of money, a few cents, US dollars, to do specific tasks. Often they don't take very long, or they can be chopped up into smaller pieces. Some researchers also use that for their research. It's a quick way to gain data. You just pay people to quickly get your data set. But this goes also in the training or labeling of data for AI systems. So there's people in India perhaps sitting and just stupidly sort of like labeling, like I did, faces or other types of image data, or in this case, working on voice data. Putting their labor in it. But then we have even other types of labor that's perhaps not paid at all. You as a user, you're recorded, and your voice recording is usually stored in the device, used to train previous generations of the device. You're also working for the company in this sense. We also, probably most of us have been on some website where you've been asked to label or like identify some traffic lights, some stop signs, some trucks. That's also a way of getting unpaid labor. It just costs you a few seconds to click these things to get into the system or whatever like login page you want to use. But at that moment, you're also contributing to this labor that makes AI possible. So that's like another way where we can see what's actually going on in these systems.
Mm. Yeah, and maybe the next slide as well, which is a slide of a mine. And one of the things that they talk about on this anatomy of an AI is that it's not only labor connected to what we necessarily think of computer labor or AI labor or labor where you sit at a desk and click things in front of your telephone or the computer. There's lots of other actual physical labor that's involved in the production of AI systems. And those AI systems not only require, for example, mining of oftentimes rare minerals, with all of the conflict and labor issues that arise around that, but it also involves labor of transporting those materials from one place to another, labor of producing parts of a computer in various countries from those materials, then transporting that to other places. There's so much labor behind the actual production of the hardware or the materiality of this AI system, even though we imagine it as being sort of ephemeral out there on the internet, just speaking with us. There's lots of materialities, lots of labor issues with those materialities, labor issues with the ephemeral computer programming aspects of it. And then there's the whole power structure, the infrastructure for having electricity that is involved in that, in the use of it. The transportation infrastructures, lots and lots of elements of our infrastructural and material and social world. So when we read this text, which is a modern text, but I would at this point say it's actually also one of the foundational texts of current discussions around AI, what we ended up seeing was that it awoke many questions from within our interdisciplinary group in the seminar, from very different fields. We had a couple of old Marxists with us. We had a couple of young Marxists with us as well, who were really interested and adamant about talking about the labor issues involved in the production of AI. We also had some sociologists and some STS people, science and technology studies people, who were really keen on talking about how the production of the knowledge, for example, and the production of the relationship between you and your AI system, which is going to set the timer, is both embedded in a very context-specific place, probably your kitchen, but also relational. Where is that interaction happening? Is it with you? Is it with the system? Is it in the relationship between the system? What are the temporalities of that? Then it became quite philosophical. We have a couple of philosophers with us too. But we realized that this AI system could be approached and analyzed by so many different disciplinary steps or disciplinary perspectives, and each perspective showed or made visible different aspects of the AI system. And there I think it became really great that we had this very cross-faculty and also cross-disciplinary seminar where we could start to hear each other's ideas about them.
Absolutely.
Yeah.
I mean, we also have people very interested in the environment. So the mine is, of course, also showing like where are the materials coming from, where are they kind of coming out of the earth. Like there's research also in Leo Humanities looking at kind of, what happens when you extract these materials from places where maybe, it's not actually beneficial, or like you kind of get these like huge holes in the ground that are actually, go around and like look at kind of sites where they built something. You can really see how the earth is kind of like ripped open, if you will. I think that's also like a perspective that was a bit new for me, like coming from a more technical background. I never sort of thought about this in this way, but kind of asking these questions, what's happening here? And what does it take for me to ask, can you set a timer for 6 minutes that I could easily put on kind of a manual sort of timer, or even just look at the clock that I maybe have in my home. So it's really sort of like interesting, I think, to open up this whole box and really look what's happening to make this really small thing possible. And what kind of perspectives can we come with, especially for these devices that are already in our homes.
Yeah.
Should we move on?
I think we should move on.
So finally, we are interested also in how do AI systems see the world. What do you see here in this picture?
On the left, a dog, and on the right, a cat.
Yeah, so we got the answer, a dog and a cat, also with the directions left and right. Computer doesn't see that necessarily. The computer sees white pixels, blue pixels. Perhaps if you put that in some edges, you could see, okay, there's a transition. If you move from the upper corner there, eventually you get some sort of like almost straight line there with the cat, or here the legs also. The computer doesn't know that this is a cat and a dog unless you tell them to learn this. So I'm sure you heard sort of that you can train AI systems to take a huge amount of data, pictures of cats and dogs, and then train on them and train on them and train on them to sort of eventually tell them apart. Technical or sort of like data scientists like to say that this is a bit like a child sort of encountering many, many examples. You can maybe question that also, but it's quite interesting to think about, okay, how does a machine sort of like learn this? By getting some labeled data that is telling, like, this is how a cat looks, this is how a dog looks, these are example images, now go and like dig your way through it and kind of sort them on different piles. I think you could imagine the same thing if I gave you some image of some really kind of like strange object and I tell you this is a, I don't know, booba and this is a kiki, and you just sort of sort them on different piles, and eventually, hopefully, you got most of them correctly. But then some of them might still be wrong. It doesn't really matter so much for machines, unless sort of like it maybe gets a real world application. I think a really famous example that I've heard many times that my computer vision professor also always told was sort of when the military was starting with these vision systems, they were training the computers to recognize images of tanks and no tanks. And the computer eventually was able to do that, but then suddenly it's kind of stopped working. And what they found out eventually is that the computer hadn't learned to tell apart like tank versus no tank, but the images were taken in different lighting conditions. So basically the system had learned to tell apart a blue sky from a gray sky. So I think it's kind of important also to ask, what did we actually teach here, and is it the thing that we thought that we taught? We kind of, I think, taking a humanities perspective, are also interested in looking a little bit deeper at the cases where it's not just about cats and dogs, but where it becomes more critical. What if you cannot get soap out of the soap dispenser, automatic soap dispenser, because you don't have the right skin color? Nowadays we're washing our hands very often, so it might be actually quite an annoying issue. What if your camera on your phone is not focusing on your friend with darker skin? It can only recognize your face, or even worse, when you upload the picture to some database, your friend gets labeled as a gorilla. What if your face has a lower chance of getting recognized just because you're not a white man? These are not things that I just make up here, but these are actually all cases that have really happened. We have one project that we wanted to introduce because we also read the original paper, and I recommend you to take a look at it. There's sort of like a website with like very nice animations from Joy Bulamwini, who worked together with Timnit Gebru to write this paper on gender shades, which we're going to discuss more.
The paper itself stemmed, if I remember correctly, from experiences that Joy had when she was working in a lab at MIT, if I remember right. Yes. And they were trying to do face recognition technologies. And Joy, who is African American, was not getting the technology to work at recognizing her face. No matter what happened, she could not get this technology to recognize her face. And one day, just out of sheer frustration, or if it was they were getting ready for a party, the story goes different ways, she put on one of those white masks that, there was that film, what's the name of the guy? Anyways, a white mask. And suddenly, just a white plastic mask with no paintings on it, suddenly the face recognition technology recognized her face as a face. And she was like, what's going on here? So they set up a study to try to figure out what types of faces the technology would recognize or would not recognize.
Yeah, so we're going to try and walk you through it. It's a bit complicated. But essentially what they try to do is to compare different face recognition systems that were labeling gender, that were looking at a picture and saying, is this a man or a woman? So first, they had the system just sort of like check for all the people, and we're going to just pick out one of the systems that they evaluated. They evaluated several systems, but Microsoft is a company that I'm sure you all know, and they also had a system that was doing that, looking at images, telling, is it a man, is it a woman? So on the data set as a whole, Microsoft software was actually doing quite well, 93.7% accuracy, so about sort of 6% of the cases were labeled wrong. So then a man gets labeled as a woman, or a woman gets labeled as a man. What about these 6% that were labeled wrong? To kind of like understand what's going on there, like they kind of split the data set and looked at just men and women to see, is there a difference? Yes, there actually was a small difference. When they just looked at the man, the men actually got recognized a bit better, and the women got recognized a bit worse. So then for the women, it just went down to 90% accuracy. Still quite high. I mean, you could say, like, yeah, what difference does it make? Just these few cases. Then they also split it they labeled their data set according to some skin shade. That's where the name comes from, gender shades. Scala to kind of see, okay, is there a difference for darker and lighter skinned people? And I should actually say that they couldn't use any of the existing data sets because they were all skewed. There was only like white people in these data sets with very small representation of people who were not of white color. So they had to make their own data set for this entire process, where they took politicians from different countries, including Sweden. So it's quite interesting, I think, to say that. But yeah, so they looked at like what happens when we look at the skin color. And again, for the white people, it increased. They got 97%, so quite an increase. But accordingly, for the people with darker skin, the accuracy decreased to below 90%, actually. But they weren't done yet. They split it up, looking at different genders and skin colors. And for the guy down here, white men, the accuracy went up to 100%. It was always labeling the gender correctly. For the black woman up there, not so good news. In Microsoft's data set, they went down to, I think it was, it was about 80%, or below 80% actually. But in the other systems that they evaluated, it was even worse. It was about 65%. That means out of 3 black women, 1 will be recognized wrongly. And I mean, this is about gender recognition, so maybe it's not directly applicable, but imagine you're at the airport and every 3rd black woman gets pulled out, yeah, something is wrong with your face. System doesn't work. And I think this really shows that probably the developer, like a white man, actually thinks that they are doing a good job. They can't even discover that there's a problem when they're there in their lab and they test the system. Hey, we got it to work. It works amazingly. But then when you take it out to the world, where you have a much more diverse population, it stops working equally well. And I think this is like a very important thing to highlight here, that it's really maybe not even with bad intention in the first place. But yeah, who is actually part of evaluating these systems? Can we even discover that there's a mistake? So yeah. I think this was one of the biggest questions, perhaps, that we also discussed in the seminar.
Yeah, and it also brought in questions on what sort of data we are using to both develop and test the systems, of course. So it was interesting that they had to go out and find different faces because they couldn't use the original body of data to test it because there weren't darker skinned faces in that the body of data. So it really points out the importance of thinking a bit broadly or critiquing the data that is laying at the foundational level of our AI systems, and critiquing it possibly from what we would probably here at the university call an intersectional perspective. So thinking beyond simple binaries of male-female or even a non-binary understanding of gender, but thinking beyond gender to include something like race, or to include something like geographical location, class. These are typical categories that we bring in, ability or variable abilities, to think about how data can be viewed or seen or constructed or produced differently. It was one thing, but also then what happens when an AI system or anything we're developing using data is moved out to the wild, and how important it is to start testing that in the wild and think about the contexts and the use in practice rather than just the design of. And of course, this is nothing that everybody, one person can't do all of this, but it is something that when we're starting to think about systems that we want to put forward and push out into a wider society, into a context, that we could also think about what that context is and start to problematize it. And then what happens when that system moves context? This is another thing that comes up, I think, a lot, is when we produce a technology, be that an AI system or a soap dispenser, we are producing a physical material artifact that has technical obduracy in it, obduracy being stubbornness or inability to be manipulated and moved and changed very quickly. It's obdurate, it's still, it's slow, it's stubborn. That technical obduracy is going to then carry with it the value systems based on the data set that it was developed out of, and take that out of the lab into new environments, take it from one country into another country, take it across oceans into new cultures, into different subcultures and uses. That technical obduracy is bringing with it the values and norms that it was developed within. And these were, now we're getting very moral and highfalutin, but it was something that became really apparent in this article. The great thing about this article is it had lots of algorithms in it too. So it was so super easy to use as a way of starting a conversation across our disciplinary divides. I encountered it and thought it was a bit scary and difficult. I'm not used to algorithms, but it actually spoke a lot to the people I was in conversation with who are working over at the technical faculty. So it was a really fun article for us to start using to discuss.
Yeah, I think it's very interesting to sort of see that it's like, I mean, this is just sort of like one article, and I think there's so much more sort of like to map out, but we often also don't even have the resources. So I think it's really important to like start this discussion. And I think from a humanities and social science perspective, what we can come with is like a generally more critical perspective where we, even if we can't always perform these like time-intensive studies where you can look at the data set in detail, I mean, you need to actually like, you know, open the folder with all these images, download this like huge amount of data, look at the different images. To sort of find this, but to generally also come with a question, like perspective that asks these questions like, what kind of data actually went in there? Who developed it? What does this system actually know? If you tell me like, oh, yeah, we trained this system sort of like to recognize something that is very specific, sort of like it's more important to ask, what is it actually sort of recognizing? If I say like, yeah, it's distinguishing cats and dogs, is it actually doing that? Or is it maybe looking for the color or some sort of shape? So I think, yeah, it's quite helpful to sort of like really take this perspective and scrutinize things critically. And I think here at the university, that's also part of my research, is really to go out and study technology in the wild, in people's homes, sort of like in settings where you can actually find also some of these problems. I think for voice interaction, it's like a similar thing, like kind of what do they actually pick up? How do people actually even speak to these devices? Is it sort of responding to the way that people talk at home, maybe in dialects? Children having like very high-pitched voices that are usually not at these places where they develop these devices. I think, of course, nowadays companies are also learning, but especially when something new gets developed early on, like the humanities and social sciences can come in with like a perspective that could be helpful to have from the beginning. Mm-hmm. So I think that's also some perspective where we train like a little bit how to, learn about these systems, how to make our own research relevant to a more technical field. So I think that's also one outcome of the seminar that we started.
Yeah.
Yeah, good. I think it's time to wrap up so that we will have some time for questions. Yep. Just to summarize again, we've looked at what systems actually know about the world and who it is learning from. We set a timer to 6 minutes to boil an egg and learned what it takes to realize an AI system. How does it impact human labor and also planetary resources? And then at the very beginning, we asked the very big question, what does intelligence actually mean? So what do we actually mean when we talk about artificial intelligence? And are these systems in any way actually intelligent? So I think we will leave some time for questions.
Yeah, thank you. Thank you for coming.